Okay, so today's starter problem is this. You're given an acceleration versus time graph. And the acceleration is a constant 3 meters per second every second for 3 seconds. And then the acceleration suddenly drops to 0 for the next 2 seconds. Now, assuming that your initial velocity is 0, I want you to draw the velocity versus time graph based on this. And then, assuming your initial position is 0, your starting position is 0, I want you to draw the position versus time graph using the velocity graph. Okay? So, let's do that, and let's work our way up. So I'm going to zoom in, and we'll do this first. Oh, so if you're doing this on the video, pause it right now and try and do this yourself. Don't just sit there like a bum and watch me do it. Okay, try to do it yourself. All right, so stop, start. Okay, so here's how you do this. You need to be able to scale this velocity. And so the first thing you want to know is, okay, what is the biggest velocity I'm going to get? Well, first of all my acceleration is positive, and I'm starting with 0. So I'm going to have a positive final velocity. And remember that the area underneath an acceleration versus time graph represents my change in velocity. So the area, there's no area here, so all the area is in that first 3 seconds. And so it's base times height. So the base is 3 seconds. Okay, times the height, 3 meters per second squared, or meters per second every second. You can do that either way. And what do you get? This is 9, what? Meters per second. So that means my maximum velocity is going to be 9 meters per second. So I need to scale this appropriately for that. Now I'll just go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2, 4, 6, 8, 10. And so I know that at 3 seconds, my velocity is 9 meters per second, because that's my change in velocity. I also know this. Acceleration is the slope of my velocity versus time graph. And so since this acceleration is constant, that means this has a constant slope. So this is going to be a straight line. Like that. Another way of looking at it is this. Every second, I change my velocity by 3 meters per second. So I start at 0. At 1 second, this should be 3. Oh yeah, look, it's right there. And then at 2 seconds, it should be at 6. And then at 3 seconds, it should be at 9. Because I'm increasing my velocity by 3 meters per second every second. Does that make sense to everybody? And then, what happens? Well, my acceleration is now 0. Acceleration is the rate at which I'm changing my velocity. So I'm not changing my velocity anymore. So what's going to be true about my velocity for those last 2 seconds? It's going to stay 9 meters per second for those 2 seconds. And there's my velocity versus time graph. I'm all done. Okay, so now it's time to draw the position versus time graph. All right, now, so I need to know, in order to scale this, okay, what's my maximum change in position going to be? Well, I can do that by knowing that the area underneath a velocity versus time graph represents my change in position. I'll be changing that position from the origin. So if I just figure out what this area is, I know how to scale this. Well, this is two shapes. I've got this triangle and this rectangle. So what is this triangle? Well, it's 1/2 the base times the height. So 1/2 the base is 3 seconds. And the height is 9 meters per second. Okay? Equals, well, what's 3 times 9? 27 divided by 2. So this is 13.5. And the seconds cancels the seconds, so I get meters. So that's the triangle here. Now what about the rectangle? Well, the area of a rectangle is just base times height. So the base is 2 seconds from here to here. And the height is 9 meters per second, again, from here up to here. 2 times 9 is 18. And again, the seconds cancels, leaving meters. So the total displacement is going to be 3 plus 8 is 11. So you get 31.5 meters. So that's my total displacement. So I have to scale this so I get to 31. So what I'm going to do is I'm going to go 5, 10, 15, 20, 25, 30, 35. So I'll go 10, 20, 30. Okay, and so that'll work. Now, there's a change at 3, so I'm just going to kind of go up like this. That's the advantage of doing these things with a kinematic stack. And my starting position was given to be 0. Now, at 3 seconds, I know what my position is at 3 seconds. It's 13.5 meters. Well, where's 13.5? It's right about here. If this is 10, this is 15, so 13.5 is right about there. Now, I can draw this now. And then at the end, at 5 seconds, it's 31.5. So here's 31.5. It's kind of over here. Somewhere around like that. But now I got to get the shape of the graph right. Now watch what I'm doing here. Velocity describes the slope of your position versus time graph. So the velocity starts at 0, which means that this has a 0 slope. At 1 second, it has a slope of 3, so we're going to gradually increase the slope to about 3. And then at 2 seconds, it has a steeper slope. So basically, the slope increases and increases. And then you get here. Oh, I didn't draw that very well. This should be this should be a little bit smoother. But you start with a 0 slope, increase your slope until you've reached your maximum velocity. That's the maximum slope. Then for the last 2 seconds, the slope stays the same. And there's your position versus time graph. So, all in all, here's the whole thing together. You should be able to use these ideas of area underneath the graph and slope, starting position, starting velocity, and all that to draw these graphs. And you will have a problem very similar to this on the exam. So if you need, and I will post this on YouTube, so if you need to go through this whole thing again, all 10 minutes of it, okay, it's pretty exciting stuff, so, enjoy.